Good morning, class.
Good morning, sir.
Yes, how are you? How was your weekend? Was good. Good. Welcome to this class. Today we are going to look at telecommunication principles. We are going to look at AM modulation, another AM modulation. We are going to cover principles. Of AM modulation. Another principle. Of course, we will cover the equation, the sinusoidal equation for AM. Equation for AM. That is the last thing we are going to look at in today's session. And maybe before we introduce this subtopic, I'd like to confirm those who are not around and those who are there in today's class. Robinson?
Present.
Alan?
Present, sir.
Charles?
Present, sir.
Hillary?
Present, sir.
David?
Present, sir.
Rotich?
Present, sir.
Yes. Welcome. Let's continue. Before we proceed, I'd like us to remind ourselves what we covered in our previous class. Yes, Helen?
We learn about types of modulation.
Yes, very good. That is correct. We looked at types of modulation. Yes, any other thing we learned? Yes?
Among the types of modulation,
Yes.
what we call frequency modulation.
Yes, we also looked at frequency modulation as one of the types of modulation. Very good. Any other thing we learned last time? Just remind ourselves. Yes.
Amplitude.
Amplitude modulation. That is AM. Is that the case?
Yes.
Yes. Any other thing maybe someone to remind us? We've forgotten to mention. Yes.
Also discuss about phase modulation.
We also discussed about phase modulation. These are the three types of modulation we discussed, and we just introduced them and we have not yet covered them. But today we are going to discuss amplitude modulation as our first type of modulation. And before we proceed, maybe if one of you can remind us the meaning of modulation in communication so that we can proceed. What is modulation? What is to modulate a signal? Yes, anyone with an idea about this one?
So this is where we take a signal of a lower frequency and we mix it with a signal of higher frequency for transmission purposes, mostly for long distance.
Okay, very good. Robinson has reminded us that modulation is that process of mixing two different types of signals. A message signal with a carrier signal. So before you transmit a signal, maybe you are communicating to your friend who is in Nairobi, and you want him to hear that sound, the type of communication you are trying to transmit. Of course, it is of low frequency, and therefore you must improve its frequency for you to transmit it to Nairobi. And that process is what we call modulation, whereby a message signal, frequency of the message signal is actually interfered with by actually adding a carrier signal frequency. By adding the two, you are able to come up with the modulation aspect part of this topic. And now with that, today I want us to look at AM. All these are types of modulation. Now, what is an AM modulation? Just from the word amplitude, modulation. So we say modulation, that aspect of changing some of the variables of the message signal for it to be transmitted. And now we are actually dealing with the amplitude. How many of you have done physics in high school? Yes, almost all of you. See here?
Yes.
Yes, you can remind yourselves about this wave. A wave. This is a wave. And on this side we have what we call the amplitude. Very good. What about this side? Against time. Syllable. Yes, so it is very clear that the peak point of a wave is its what? Amplitude. And now the distance along the x-axis is now what? That is the time period. Is that okay?
Yes.
Yes, very good. And with that, today we are going to look at AM. And now with the AM, of course, we are going to interfere with the size of the amplitude. Because AM in full is amplitude modulation. And therefore, the factor that we are going to look at in any signal that is to be transmitted is its what? Amplitude. Is that okay? So the amplitude is going to be changed in accordance to the carrier signal frequency. And now with that, I want us to introduce several signals that we discussed last time. We have communication signals. Just remind ourselves of these two signals. Yes?
We have information signal.
Very good. We have this, what we refer to as the information signal. Is that okay? The other name for information is message signal. Yes, any other signal? Yes, carrier signal. Very good. We said we are going to use what? Carrier signal. These two types of signals. And when it comes to FM, of course, there will be that message signal and again a carrier signal for you to perform modulation. So, one of you to remind us how these two signals look like. So they'll have actually to draw the signal wave of the two. The carrier signal wave and the information signal wave. Maybe if you can remind us how we bring last time. Yes, Anna? Can do it from here.
Okay, I'm going to show the message signal.
Yes, very good. Alan has drawn for us this what now referred to as the message signal or the information signal wave. Now, what about for carrier signal wave? How is it drawn? Is someone to come and do it from here? Yes. Hope you updated your notes last time. I sent out the notes. Were they written?
Yes.
Yes.
Yes, very good. Are your notes? Good. Good. Have you written the notes?
Yes.
Okay. Get it? Okay, good. Yes, very good. Very good. This is the carrier signal. You come to realize that for a carrier signal, the amplitude is same. And it has a high frequency. So it's only that the frequency should be shown as to be so high in such a way that it looks like with so many what? Are you getting the point?
Yes.
The amplitude is same and the frequency is high. Is that okay? So we are using the carrier signal. You mix it with the message signal for you to transmit that message, and at the end of it, the demodulation is going to take place. The difference of modulation is demodulation. Sawa. Yes. So very quickly, let us derive the formula now for this. Dear learners, at this point, we're able to start deriving the amplitude modulation wave, and with that, we are at this point where the amplitude of the carrier, we are talking of this amplitude. Where is our carrier frequency? This one. This amplitude, you add what? The modulation factor multiplied by the amplitude of the carrier cos lambda times. Is that okay?
Yes.
For the message signal, for the carrier signal. Now we are trying to open the brackets. DC plus DC plus plus it is DC times 1. Are you seeing that?
Yes.
Here we are getting EC, but M, the modulating factor, cos lambda MT. But remember, we have not yet multiplied by that. Okay? EC cos lambda. Is that okay?
Yes.
Plus modulating factor EC cos T multiplied by cos omega. Is that the case?
Yes.
Now, from a trigonometry identity, what have we noted? Assuming that our lambda mt, omega ct, and our a and b. So we are assuming we have cos a dot cos b, which is equal to, who can give us this identity?
Is equals to
Yes.
cos
Yes. Yes.
in bracket cos A plus B
Plus.
B close the bracket
Yes.
plus
Cos A plus B. A plus B
plus
plus
cos A minus
cos A minus B. And it's very clear that we're going to have our is equal plus modulating factor. Then we're going to relate all these in that. It becomes half very good. Cos plus cos plus cos
cos WMT
W
minus
is WMT plus that. See how back up paper sir?
yes.
Then we have this cos A minus B, which gives us this minus that. So it is cos that minus cos that. Cos out. Yes. And now with that, we have actually identified that we have how many types of frequencies here? For AM, we have 3. 1 for carrier, the C, it denotes the carrier. 2, we have the upper side band, and this one with the negative is the lower side band. And now these are the principles for AM modulation. Is that the case? Yes. Now, where 1, it consists of the carrier signal. 2, AM consists of the upper sideband. 3, it also consists of lower sideband. Is that okay?
Yes.
So you can define your upper sideband as the summation of the message frequency and the carrier frequency. How can you define lower sideband? The difference, because it is minus. The difference between the message frequency and the carrier frequency. Now, learners, I want to give you the assignment. And before I give you the assignment, I wish to know what you have covered today, what you have understood in today's session. Everyone? Yes, Charles? You have not talked today?
Modulation carries in the AM modulation, we have the carrier frequency, we have the upper sideband and the lower sideband.
Very good. Charles, that is correct. We have learned about the principles of modulation, and we have identified that AM comprises of 3 types of signals. Is that the case?
Yes.
Learners, give you the assignment whereby we want to use the formula we have derived to calculate this question. The question will be submitted tomorrow before we meet our second session. A 2500 kilohertz carrier is modulated by audio signal with frequency span of 50 to 1500 Hz. What are the frequency of lower sideband and upper sideband? Do that work. In case you have challenges, please consult. I wish you a